Good afternoon and welcome to another technical webinar from CCSI. This one's called Spot Run Across Cloud Platforms. It's how to use Spot instances to save significant costs in your cloud operations. So just the quick obligatory marketing slide about CCSI. CCSI has been around for 40 years. We do infrastructure and data center services such as routing and switching and hyperconverged and storage and VMware. We do third-party maintenance with priority response, break fix, and we can be a good SmartNet replacement. We have cloud services where we do containers, Kubernetes, Microsoft services, Office 365, migrations, etc. And we have a cybersecurity and physical security practice where we can protect you against ransomware and DDoS and all sorts of security and vulnerability assessments, whether they're for compliance or just for your peace of mind. And we have a 24/7 NOC and SOC, which are based here in Bohemia, New York. And they are 24/7. They provide managed services, a customized SIM, and they are SOC 2 Type 2 compliant for those of you in the financial or insurance worlds. Who am I? I am Joe Goldberg. I'm the Senior Cloud Practice Manager here at CCSI, so pretty much everything cloud kind of falls into my world. So today we're going to talk about Spot instances, and they are good for cost savings. You can really save up to 90%. I know a lot of cloud cost saving tools will tell you can save up to 90%, but that's like you know really have an inefficient infrastructure to begin with. But with Spot instances, you really can save up to 90% with relatively not a lot of work. So of course, Spot instances are available in all three major cloud platforms. Of course, they all call it something different because that's what they do. In AWS, they're called Spot instances. In Google Cloud, they're called preemptible instances. And in Azure, they're called Spot virtual machines. They work pretty similar across each platform. There's some minor differences, but we're going to concentrate on the AWS Spot instances just because they're the largest player in the space, and you have to pick one. So Amazon EC2 purchasing. So if you're buying infrastructure as a service or virtual machines from Amazon, there are effectively three primary purchasing options within AWS. You have an on-demand instance where you're paying for the compute capacity you have excuse me, by the second. There's no long-term commitment, and it's good for things that have spiky workloads and where you need to really define a need and the machine needs to be there no matter what. You have reserved instances where you're committing. So you're saying for 1 or 3 years, I promise I am going to have this machine or a machine of the same class. And with that commitment, you get significant discounts. And that's good for, a steady state application. You have a database server for an application you're going to have around for the next 10 years. So you might as well put it on a reserved instance. You can get increased discounts if you pay upfront as well. And then there's Spot instances. Spot instances are Amazon's way of selling spare capacity. And they sell it at up to 90% off what the on-demand costs are. The price is determined by the amount of capacity that's available and the demand for it. It's great for fault-tolerant workloads, flexible workloads, stateless workloads, because if demand picks up and Amazon needs that capacity back, they're going to give you 2 minutes warning and take it back from you. The basics of a Spot instance are price changes are infrequent. It used to be when they first came out, there was a market where people would bid on them, and it was just a mess. It was like the stock market. But now the prices change infrequently, and the prices are based on the long-term supply and demand of the capacity in each pool. And a pool is defined by the class of machine, the region, and the availability zone. I have another slide a little further down that will break that out a little better. All you have to do is just request capacity, and you pay whatever the current rate is, and that's it. And interruptions to the machine only happen if AWS or Azure or Google need excess capacity. Nobody's going to outbid you and then take the machine from you. The only time it happens is if the cloud provider needs increased capacity. In Amazon, Spot instances are integrated with Amazon services such as auto scaling, batch, EMR, data pipeline, Elastic Container Service, Elastic Container Service for Kubernetes or EKS, and CloudFormation. But there's also integrations to external applications that people are using for infrastructure as code and for automation of their CI/CD pipeline, like Cloudera, Docker, Kubernetes, Bamboo, and Jenkins, and Terraform. They can all speak directly to Amazon and get information and spin up Spot instances. So here's kind of roughly how a Spot pool works. It gives you instance type flexibility. So in the example on the left, we're using a C4 instance, and you have, let's say we're in a region with 3 availability zones, 1A, 1B, and 1C. And you can see that if I'm looking at an 8XL, which is a humongous machine, there's a pool for C4 8XL in 1A. There's a separate pool in 1B and a separate pool in 1C. And you can see the difference in price. So you can choose which one has the cheapest price at that time. If you needed 2, you would assumably take 1B and 1C. And you can also look at the difference based on the on-demand price as well. So each pool, each instance family, each instance size, each availability zone, each region is a separate pool. So what about these interruptions? What is the rate that the cloud provider is going to take stuff back? There really are minimal interruptions. Over 95% of the instances over the last year were not interrupted in their first 3 months. So that's pretty good. You can go 3 months without an interruption. But keep in mind that you're probably using this with an application that is already fault tolerant. Spot instances are really optimized for stateless, fault-tolerant, or flexible workloads, or any application that can have part or all of its work paused and resumed or restarted. All of that can use Spot and really benefit from it. There's a 2-minute instance termination warning. It's a notice that's sent out via metadata or through a CloudWatch event, and that should give you enough time to both grab the checkpoint, drain any elastic load balancers you have, and you can start and stop or hibernate the machine before AWS takes it back to allow you to move it to another Spot instance quickly and get you back up and running. So if you're thinking about, is your workload Spot ready? Well, look at your workload and say, well, is it stateless? Is it fault tolerant? Is it flexible? Can it be in any availability zone within the region? And does it matter if it moves from availability zone to availability zone? And is it instance flexible? Like if it's on a M5 large, can it move to a T3 large and still operate just as well? And all the services that are using Spot instances should be loosely coupled. In case one goes away, it doesn't tear your entire infrastructure down while you're waiting for the next one to come back up. And this is where our containers and Spot instances come together. Containers and Spot instances, and especially Kubernetes and Spot instances, are really a perfect match. Because containers are usually stateless. They are fault tolerant, especially if you're using Kubernetes. Kubernetes is going to do everything in its power to maintain its current state. So it will automatically rebuild any containers that are destroyed in a lost Spot instance. And so those are great fits for Spot instances. You can deploy containerized workloads and easily manage clusters at scale at a fraction of the cost. We do this at CCSI. We moved our EKS clusters over to Spot instances, and we saved, on average, about 72% in US East. Spot instances can be used with Amazon's ECS, which is their container service, or Kubernetes to run any containerized workload. And that's whether you're using Kubernetes, the native Kubernetes in AWS, where you're controlling the master, or whether you're using Amazon's EKS, where Amazon is controlling the master. Spot instances will work either way. So just to give you a quick example of how it works using Amazon EKS, here's just an EKS environment. You have Amazon controlling the master node up on top, and the user is controlling the worker nodes down on the bottom. So you have a node in AZ1, 2, and 3, for example. And obviously it's all controlled with kubectl, or if you're using AKS, you're probably using EKS ctl. Amazon EKS and Spot, here are the challenges that you're going to have, or the process you need to go through. You need to acquire the capacity for the nodes you're going to be running. You need to be able to handle any interruptions. You need a scaling mechanism. So there's two types of scaling. There's horizontal pod auto scaling. So if a pod gets to 80 or 90% utilization, you might have a rule in there that spins up another pod, or cluster auto scaling. So if a node is running out of capacity and you're trying to get another pod launched, you need to now launch another node. You also need to respect all taints, tolerations, and affinities that are defined in the configurations. And you need some basic tooling. There's a hard way of doing it, which is the way, I guess the traditional way. It's a multi-step process, but this will get the job done. You can use something like EKS ctl and add a diversified Spot node group. So for this, you're looking at something in US West in 2 availability zones with a bunch of different machine types that are possible. You need to be able to handle interruptions. So that's done with a daemon set that's running on each node. So now you'd have to do something like write a script like this, which is going to go look and see if your node is going to be terminated if you've gotten your 2-minute warning. And if it has, you need to then drain the node and create a new node and move everything over to it. And part 3 is you need to be able to do the auto scaling. So you need to be able to scale for pods based on CPU, and you need to be able to scale for nodes based on the availability of space on each node. And the cluster auto scaler checks every 2 minutes to see if you're if you need to do an upgrade, and then it has a cool-off period of 3 to 5 minutes after it makes a change to kind of keep you from bouncing back and forth and end up in that kind of environment. And then you need to write configurations to handle all of your taints and tolerations and affinity pools and stuff like that. All of this adds up to a fair amount of code and YAML files that you need to be able to manage. And it doesn't solve the problem of meeting application demands and balancing that with minimizing idle resources. You want to try to have all of your nodes running as close to 100% utilization all the time as possible, so you're maximizing your utilization. But you also don't want to make it so that you end up with pods that end up in a pending state because you don't have the infrastructure in place to actually launch them. You have no node with enough room for the coming pod. So you need to be able to find that balance. CCSI has partnered with Spot Ints to be able to assist in making this a much easier process. So no more playing Kubernetes Tetris. If you're looking at the nodes in your Kubernetes environment, you're looking at, do I have room over here to fit this node? Do I have room over there? Where do I need to move stuff around? So the goal would be to no longer have to do that. And the way to do that is to treat all containers as first-class citizens, whether they're defining instance size, type, lifecycle. It's determined based on the task requirements. And of course, you have to honor all the labels and everything else. So if somebody says, I need 1 container and one pod, and it will fit in a M3 medium, spin up an M3 medium. But if somebody else comes along and says, I need to do some machine learning, so I need a GPU pod, well, if you're the administrator and you haven't added a GPU node to your configuration, it's just going to sit in the pending state until you get around to it. Same thing, you need to be able to respect if people want to specify that they want an on-demand instance, that this node cannot, or this container cannot be on a spot instance because it cannot go down. You need to be able to respect that as well. So show me the numbers is how the spot inst is able to organize pods into nodes to maximize the cost savings. So very often, let's say you have one pod that requires 6 gig of RAM and 1.5 virtual CPUs. You could use an M5 large, and with a spot instance, it would cost you 9.6 cents per hour, and you'd be at about 75% utilization. If you go to 2, well, now you're going to need two M5 extra large. I'm sorry, you're going to need to go to an M5 extra large to get those 2 on there. You're still going to be at 75% utilization, and your cost is still about 9.6 cents. When you scale up to 5, though, if you go to an M5 2 extra large and go with a bigger machine, you can run at 93.75%, and then your cost per pod goes down to 7.7 cents. So you reduce the cost by 20% just by cramming as much information, cramming as many pods and right-sizing the nodes to get as much on each one as possible. And the same thing works with instance families. So Spotins will be able to figure out I have one pod that's running on a C5 extra large with the same 6.5 gig and 1.8 virtual CPUs, and I'm paying 17 cents per pod. If I would go to a second one, I can change the whole class of the machine and move to an M5 extra large and run at 90% CPU, and the cost per pod goes almost in half at 9.6 cents. So I'd save 43 cents. And that's kind of the automation and on-demand calculation that Spotins can give you. So this allows you to kind of achieve a nodeless type experience. There's no management or underlying infrastructure. You don't have to worry about, you as the administrator don't have to worry about how many nodes you have and what class they are. You let Spot worry about that. It's going to figure out the most effective way to scale your infrastructure. You scale by request based on real-time requirements, so you don't end up with pods that sit in the pending state for 3 days because you didn't have the right instance type defined in your configuration. Spot will take care of that automatically. And utility billing, you pay only for what you use. You eliminate waste. If somebody gets rid of a giant pod, Spot will reorganize the nodes to try to limit the cost as much as possible. And you can scale to 0. You can scale all the way down to 0. So if your Kubernetes infrastructure is not being used for a weekend, or you're moving to another infrastructure, you can scale it all the way down to 0 and scale it back up if you need. And it's fast scaling. You're no longer waiting for thresholds. You can satisfy customer need immediately. So if a customer puts in for a new pod and the resources aren't there and you need to go to container-based scaling, you don't have to wait for a threshold to be crossed or for a timeout to happen. Automatically, once the customer places the need, Spot will figure out the best way to place that pod on a node or create a new node for it of the right size. So CCSI would love to be able to show you how Spot instances can save you money. We can do a 20-day test drive for up to 20 instances and show you how you can save up to 90% on your cloud costs and automate your infrastructure. You can contact your CCSI account manager for more information. Are there any questions? Going once? All right, sounds like there aren't any questions. If anybody has any questions, feel free to reach out to your account manager and they will be happy to answer them or find somebody who can. Thank you so much for attending today's webinar, and I look forward to speaking to you again.